This is MorbiCast, your quick dive into the world of medicine.
Imagine for a second that you're doing a chore. Just something totally mundane.
Right, like weekend yard work or something.
Yeah, exactly. Maybe you're opening up a dusty old cabin for the summer, or, sweeping out a shed in your backyard that hasn't been touched since last fall.
Okay.
You push the broom, a cloud of dust kicks up right into the sunlight, you breathe it in, and you sneeze.
And you don't think anything of it.
You really don't. But a few days later, you feel like you've caught, a miserable winter flu, you've got a fever, your muscles ache, you're just exhausted.
Just a typical bug, you assume.
Right. But a few days after that, you are in an intensive care unit, literally fighting for your life, and your lungs are essentially drowning from the inside out.
It's a terrifying escalation, and it really highlights why the global medical community treats this particular pathogen with such immense respect.
Yeah.
Because by the time a physician realizes you aren't just fighting off a standard flu, the window to save your life is closing really rapidly.
Well, welcome to our deep dive. Today we are opening up a huge stack of medical notes, virology reports, and clinical data to unpack a rare, rapidly fatal, and frankly widely misunderstood threat.
Hantavirus.
We're going to figure out what it is, how it hijacks your body, and why treating it requires one of the most high-stakes balancing acts in modern medicine.
The stakes really cannot be overstated here. We are looking at a virus with a shockingly high mortality rate, depending on the strain, of course.
Right.
In emergency medicine, early recognition of this infection isn't just helpful, it is the absolute difference between life and death. If the diagnosis is delayed, the supportive care required to keep the patient alive becomes a monumental, almost paradoxical challenge for the ICU team.
Okay, let's unpack this, because before we dive into the microscopic details of how this virus tears through your internal plumbing, we really need to understand how humanity first stumbled upon it.
Yeah.
Because viruses don't just magically appear out of nowhere.
Right.
There's always a trail of breadcrumbs.
There is, and the trail for this one actually begins in a war zone.
Wow, really?
Yeah. The global medical community first really documented this pathogen during the Korean War in the early 1950s. Over 3,000 United Nations troops suddenly fell ill with a completely mysterious, severe disease.
3,000? That's a massive cluster.
It was, and they were experiencing hemorrhage, massive drops in blood pressure, and acute kidney failure. The mortality rate was startling, and medical officers were completely baffled.
I can't even imagine being a medic dealing with that.
Right, and it took over 2 decades of relentless searching before a researcher, Dr. Ho Wang Lee, finally isolated the culprit in 1976. He traced it back to a virus living in the striped field mice near the Hantan River in South Korea.
Okay, the Hantan River. So that geographical location is where the entire viral family gets its name? The Hantan virus.
Exactly.
So for 40 years, the textbook definition of this disease was strictly that of a kidney-destroying virus found overseas.
Yes, primarily in Asia and Europe.
That must have made the events of 1993 here in the United States incredibly confusing for public health officials. Because suddenly, in the American Southwest, like the Four Corners region, you had this terrifying cluster of unexplained rapid deaths.
It was unprecedented here.
And these healthy young people weren't dying of kidney failure. They were dying of acute respiratory failure.
Yeah, the medical whiplash was severe. It brought hantavirus to the absolute forefront of global attention because it forced researchers to realize the virus had a completely different playbook in the Americas.
Right.
Instead of targeting the renal system, this specific outbreak was aggressively targeting the pulmonary system. It was filling the lungs with fluid in a matter of hours.
I've always wondered about the suddenness of that 1993 outbreak, though. Looking at our sources, was this a brand new, mutated version of the virus that just popped into existence? Or had it always been here and we were just kind of blind to it?
The virological evidence strongly points to the latter. Yeah. The virus and the specific rodents that carry it had been present in the American environment for thousands of years.
Wow.
So the 1993 outbreak wasn't a sudden mutation. It was an ecological cascade. It was an environmental perfect storm that essentially weaponized the virus.
An ecological cascade. Walk me through what that actually looked like on the ground.
It started with the weather, actually. The American Southwest experienced an unusually strong El Niño winter in 1992 and 1993.
Okay, so lots of rain.
Exactly. It brought heavy, unseasonal rainfall to a normally arid region. That sudden abundance of water caused the vegetation to explode, particularly the pinyon pine trees, which produced a massive crop of pinyon nuts.
Okay, so more rain equals more food,
Yeah,
which I'm guessing leads directly to the rodents.
exactly. A tenfold explosion in the deer mouse population.
Tenfold.
Yeah, it was a massive spike. Suddenly, you had an unprecedented number of these viral carriers overlapping with human habitation. They were seeking shelter in homes, barns, sheds. So the virus wasn't a new creation at all. 1993 was simply the first time the ecological alarm bells rang loud enough and tragically enough for us to finally isolate it and realize what we were dealing with in the Americas.
Wow. That changes the entire perspective. We're looking at a deeply embedded environmental hazard. And looking at our sources, this spans North and South America, Asia, and Europe. I mean, it's everywhere.
It is globally distributed, yes.
But that brings up a really crucial distinction about how it travels. This isn't a virus that floats around in the wind on its own. It relies entirely on specific reservoir animals.
Right. The vectors are highly specialized. We are talking primarily about the deer mouse, the cotton rat, the white-footed mouse, and the striped field mouse.
Okay.
The virus lives and replicates inside these rodents, but here is the critical distinction. It generally doesn't make the rodents sick. The mouse is merely the vessel.
Wait, hold on. You just said this virus causes our human immune systems to essentially nuke our own vital organs.
Yeah.
If it's that destructive, why doesn't it do the same thing to the mouse? Like, why doesn't the deer mouse end up in the equivalent of a rodent ICU?
It comes down to millions of years of evolutionary co-adaptation.
Okay.
The virus and the rodent have been locked in a biological dance for so long that they've reached a truce. The mouse's immune system recognizes the virus, but essentially tolerates it.
Oh, interesting.
Yeah, it downregulates its own inflammatory response so it doesn't destroy its own tissues while the virus quietly replicates.
And humans?
Human beings, on the other hand, are accidental dead-end hosts. Our immune systems have no evolutionary truce with hantavirus. When it enters our bodies, our immune system panics and launches a scorched earth defense.
That makes perfect sense. We are collateral damage in a biological relationship we were never supposed to be part of.
Precisely.
And the way we accidentally enter that relationship is truly insidious.
Yeah.
I mean, you don't have to be bitten by a deer mouse to get infected.
No, not at all. The transmission method is aerosolization. The rodents excrete the virus in their urine, their saliva, and their feces. Over time, that excreta dries out and breaks down into microscopic particles.
Just mixing in with the dirt.
Exactly. When you walk into an abandoned building or sweep out that dusty cabin we talked about earlier, the physical act of disturbing the dirt aerosolizes those viral particles. They mix with the dust, and you inhale them directly into your respiratory tract.
It's basically a biological booby trap hidden in the dust. You just trip the wire by pushing a broom.
That is a very accurate way to put it.
But I want to do a little myth busting here.
Yeah.
Because if you live in a major metropolitan area and you're walking past an alleyway or waiting for the subway, you're almost guaranteed to see a typical city rat scurry across the track.
Oh, sure.
Does the presence of urban rats mean city dwellers are constantly in danger of inhaling this threat?
You can breathe a sigh of relief on the subway platform.
Oh, good.
Yeah, the typical brown rats or black rats you see in urban alleyways and train stations are not the primary reservoirs for the hantaviruses that cause these severe human diseases.
Oh, really?
Right. The specific carriers, the deer mouse, the cotton rat, are overwhelmingly rural and semi-rural animals. While urban rats carry a host of other problematic pathogens, hantavirus remains an environmental hazard firmly rooted in the countryside, the wilderness, and agricultural areas.
Okay, that clarifies the risk map significantly.
All right.
So let's walk through the infection timeline based on the clinical data. You're in a rural area, you sweep the shed, and you breathe in that contaminated dust.
Okay.
What exactly is this RNA virus doing on a microscopic level once it enters your body?
So hantavirus belongs to the family Hantaviridae. What makes it uniquely destructive is its primary target. It doesn't primarily attack the lung tissue or kidney tissue directly.
It doesn't.
No. Instead, it targets the endothelial cells. These are the specialized cells that form the smooth inner lining of your blood vessels.
So it's basically infecting the Teflon coating of our internal plumbing.
Precisely. And when the virus hijacks those endothelial cells, your immune system realizes there is an invader inside the walls of your blood vessels.
Right, because we don't have that truce.
Exactly. As we discussed, the immune system responds with overwhelming force. It triggers what we call a cytokine storm. T cells and macrophages flood the area, releasing massive amounts of inflammatory signals.
And that damages the blood vessels.
Yes. This massive, uncontrolled immune response actually ends up severely damaging the tight junctions between the endothelial cells. It forces the blood vessels to pull apart at the microscopic level, leading to a condition known as capillary leak syndrome.
Capillary leak syndrome. Let's translate that for a second for the listener.
Sure.
If the blood vessels are supposed to be watertight pipes keeping your blood volume where it belongs, this cytokine storm basically turns your body's plumbing into a porous soaker hose.
That's a great analogy.
So fluid starts leaking out of the vascular system and bleeding into the surrounding tissues.
That is the exact mechanism driving the devastation. And depending on which hemisphere you are in and which specific strain of the virus you've inhaled, that leaky plumbing manifests in one of two major clinical syndromes.
Okay, what's the first one?
The first is what doctors saw in the 1993 Four Corners outbreak Hantavirus Pulmonary Syndrome, or HPS. The capillaries in the lungs lose their integrity and start leaking massive amounts of blood plasma directly into the alveolar spaces.
Which means the patient is literally drowning from the inside.
Yes. Patients develop severe pulmonary edema because the alveoli, those tiny air sacs meant for exchanging oxygen, are completely flooded.
Oh, wow.
So the patient presents with a severe cough, profound dyspnea, which is shortness of breath, and ultimately acute respiratory failure. The lungs simply cannot pull oxygen into the blood anymore.
That is horrifying. And the other syndrome, the one originally discovered back in Korea.
That is hemorrhagic fever with renal syndrome, or HFRS.
Right.
In this presentation, the virus and the immune response primarily compromise the vascular beds in the kidneys and cause systemic hemorrhage. Patients suffer acute kidney injury and experience wild, extreme changes in urine output.
What kind of changes?
Well, they go through a phase of oliguria where the damaged kidneys produce almost no urine. And that is sometimes followed by polyuria, where they lose the ability to concentrate urine and flush massive amounts of fluid out of the body.
Two wildly different medical emergencies, drowning lungs versus hemorrhaging kidneys, but both are driven by the exact same underlying viral strategy.
Exactly. Destroying the integrity of the blood vessels and causing that leaky soaker hose effect.
But here is the part that makes this a nightmare for the emergency room physician, based on the notes we're looking at. The camouflage.
Oh, the early symptoms.
Yeah, in the first 48 to 72 hours, the prodromal phase for both HPS and HFRS features symptoms like fever, severe myalgia, so muscle pain, headache, intense fatigue, and maybe some gastrointestinal symptoms.
Right. It is clinically indistinguishable from the winter flu.
Exactly. If I walk into an urgent care clinic in November complaining of muscle aches, a fever, and extreme fatigue, the doctor isn't going to look at me and immediately assume I have a rare hemorrhagic fever.
No, they won't.
They're going to tell me I have influenza or COVID-19, tell me to hydrate and send me home to rest. So how do doctors possibly solve this medical puzzle before the patient's lungs fill with fluid?
It requires immense vigilance. The differential diagnosis for early-stage hantavirus is vast. As you said, it looks like COVID-19, influenza, leptospirosis, dengue fever, severe bacterial pneumonia, or early-stage sepsis.
That's a huge list.
It is. Because the clinical presentation is so generic in those first few days, laboratory tests alone won't save you if the doctor doesn't know what to test for.
So what's the key?
The most critical diagnostic tool a physician has is the exposure history interview.
They have to act like a detective.
They do. If a patient in a rural or semi-rural area presents with severe flu-like symptoms that seem to be escalating unusually fast, the doctor must ask environmental questions.
Like what?
Like, were you recently cleaning an outbuilding? Have you been cutting brush or moving firewood? Have you seen rodent droppings in your basement? If the patient answers yes to those environmental triggers, the physician's clinical suspicion must immediately pivot to hantavirus.
And once they have that suspicion, how do they actually prove it's hantavirus and not just a very bad case of the flu? Because you can't just look at a blood sample under a standard microscope.
Right. Once the suspicion is there, they rely on specialized lab findings. They aren't just looking for the virus itself. They are looking for the biological footprint it leaves behind.
Okay.
They will use PCR testing, which searches the blood for the specific viral RNA, the genetic blueprint of the pathogen. But equally important is serology, specifically looking for IgM and IgG antibodies.
The IgM antibodies being the early responders, right? Like the sirens going off.
Precisely. If a blood test shows a massive spike in hantavirus-specific IgM antibodies, it tells the doctor that the immune system is actively fighting this specific pathogen right now.
Makes sense.
They will also look for systemic clues of that capillary leak we discussed. They often see severe thrombocytopenia, which is a dangerous drop in blood platelets as they get consumed in the microscopic vascular damage.
Right.
And they will immediately order chest x-rays or CT scans to look for the early cloudy signs of fluid building up in the lungs.
One of the most fascinating lab findings our sources mention is hemoconcentration.
Yes.
And if we think back to our leaky soaker hose analogy, this makes terrifying logical sense.
Yeah.
If the plasma, the water part of your blood, is leaking out of the vessels and into the lung tissue, what is left behind inside the actual blood vessels is a thicker, sludgier mix of red blood cells.
That is a brutally accurate way to visualize it. The blood literally thickens as it loses its fluid volume.
Which sounds incredibly dangerous for the heart.
It is. This causes the patient's blood pressure to crash, leading to severe hypotension and cardiogenic shock because the heart is struggling to pump this thickened sludge. And this brings us to the treatment phase, which is incredibly daunting because there's no definitive, universally effective antiviral cure for hantavirus.
None. We have nothing that just, kills the virus.
In most cases, no. There is no magic pill you can prescribe. For HFRS, the Renal Syndrome, an antiviral called ribavirin is sometimes administered early and has shown some efficacy in reducing mortality.
But for the pulmonary version?
For HPS, survival relies almost entirely on immediate ICU admission and the most intense supportive care modern medicine can offer. We are talking about aggressive oxygen therapy, mechanical ventilation to force air into the fluid-filled alveoli, and in the most severe failing cases, ECMO.
Let's clarify ECMO for a second.
Yeah.
That stands for extracorporeal membrane oxygenation.
Yes.
That's the absolute highest level of life support, where they essentially hook you up to an external machine that bypasses your lungs entirely. It pumps your blood out of your body, oxygenates it artificially, and pumps it back in.
It acts as an artificial lung outside the body. It buys the patient's actual lungs time to rest, heal, and slowly reabsorb the leaked fluid.
It's incredible.
But managing a patient on life support with hantavirus involves a massive, terrifying paradox when it comes to fluids.
Okay, yes. I was reading the clinical notes on this, and it feels like a total medical catch-22.
It absolutely is.
Because if a trauma patient comes into the ER and their blood pressure is crashing because they're losing fluid volume, the standard instinctual response is to hook them up to a rapid IV and pump them full of saline to get their blood pressure back up, right?
Right, that's standard shock protocol.
But if an antivirus patient is suffering from capillary leak syndrome, if they are a porous soaker hose, doesn't pumping them full of IV fluid just mean all that new liquid is going to immediately leak straight out of the blood vessels and drown their lungs even faster?
You have zeroed in on the exact tightrope walk that makes treating hantavirus a nightmare for ICU doctors.
I can't even imagine.
It is a razor's edge balancing act. If you withhold fluids, the patient's blood pressure collapses, their organs lose perfusion, and they die of shock. But if you push too much fluid to save their blood pressure, you catastrophically flood their lungs and they die of acute respiratory failure.
So what do they do?
Fluid management in these patients cannot be standard protocol. It requires microscopic precision, continuous hemodynamic monitoring, and minute-by-minute adjustments to keep them alive while their own immune system eventually clears the virus.
That is just wild to think about. The medical team is literally trying to keep you suspended between two fatal outcomes while waiting out the clock.
Exactly.
Which really brings home the ultimate takeaway from all our sources today. Since there is no cure, and surviving means surviving a high-stakes ICU battle, the only true defense is ensuring you never inhale the virus in the first place.
Prevention is our only proactive weapon, and it relies entirely on very practical, seemingly mundane environmental controls.
Like what?
It means strict rodent control in and around rural homes, garages, and outbuildings. It means aggressively sealing up any cracks larger than 1/4 of an inch where mice can enter.
And it completely changes how we should approach spring cleaning. I mean, if you were opening up an abandoned shed, a barn, or a dusty cabin, you absolutely do not just walk in and start violently sweeping the floor with a dry broom.
Never. Never sweep or vacuum dry dust in an enclosed space where rodents might have nested. The public health recommendation is to open all the doors and windows to ventilate the space thoroughly for at least 30 minutes.
Okay.
Then you use a spray bottle to douse the floors, the nesting materials, and the droppings with a heavy mixture of bleach and water.
So you wet it down.
You must wet the dust so the viral particles cannot become airborne. Only then, while wearing gloves, should you wipe it up with paper towels.
And what about people outdoors?
For campers, it means keeping food tightly stored in rodent-proof containers, choosing sleeping sites away from dense brush or wood piles where rodents burrow, and maintaining a general awareness of the local ecology.
It's essentially about reframing how we interact with the wilderness. And looking toward the future, there is some cautious optimism. Our sources note that modern vaccines are currently under development and testing.
Yes, which could eventually protect high-risk agricultural workers.
But there is also a massive looming variable on the environmental horizon that threatens to complicate everything.
There is. As we look at emerging hantavirus strains and the frequency of these outbreaks, we have to talk about climate change. We already discussed the 1993 El Niño cascade.
Right.
Environmental changes don't just affect the temperature. They directly influence the geographic distribution of these rodent populations.
Right, because if we follow the logic of that 1993 cascade, climate change isn't just about warmer summers. It is actively redrawing the ecological map.
Exactly.
If a previously cold region suddenly starts experiencing milder winters or unexpected heavy rainfall patterns, the vegetation changes. And as we've seen, when the food supply increases, the deer mouse population explodes and pushes further outward.
And as human populations continue to engage in massive suburban sprawl, pushing housing developments deeper and deeper into previously untouched rural areas, we are encroaching on their territory just as their territory is expanding into ours.
A collision course.
Exactly. Suddenly, a virus that was historically isolated deep in the agricultural wilderness is overlapping significantly with daily human habitation. We are inadvertently expanding the reach of the hazard.
So bringing all the threads of this deep dive together, hantavirus is a stealthy, highly adapted RNA virus that has maintained a silent evolutionary truce with specific rodents like the deer mouse for millennia.
Right.
It jumps to humans via inhaled aerosolized dust, triggering a massive self-destructive immune panic that turns our blood vessels into leaky soaker hoses. This either floods the lungs or shuts down the kidneys.
That's the summary.
Because the critical first 48 hours mimic a standard flu, diagnosis requires incredibly sharp detective work regarding the patient's environmental exposure. And it progresses, surviving requires an intense, high-wire active ICU intervention to manage a nearly impossible fluid paradox.
It is a profound reminder of how deeply connected human health is to the microscopic realities of the environment around us.
Yeah.
The virus isn't hunting us. We are simply stepping into its domain.
Which leaves us with a lingering question to ponder. As climate change continues to unpredictably shift animal habitats, and as human development pushes further into the wilderness, will diseases like hantavirus remain rare rural anomalies?
That is the big question.
Or are we looking at a rapidly approaching future where these biological threats start appearing in the dust on the edges of our own backyards? Something to keep in mind the next time you pick up a broom. Stay curious out there.